Good afternoon, everyone. Welcome to this Greatech Advanced Steel webinar where we're going to be looking at our introduction series to Advanced Steel, and today we're going to be introducing Advanced Steel for engineers. My name's Rob Merriman. I'm one of the application engineers here at Greatech in the UK. So a little bit about me before we get cracking. I've got 12 years of experience in the construction industry. The first 8 years of that was spent as a steelwork draftsman, working across architectural metalwork and structural steelwork. During that time I worked in two subcontract drawing offices, so that allowed me to work with lots of different fabricators working on lots of different projects in lots of different sectors. I now work as an application engineer for Greatech here in the UK. So I take that first-hand industry experience and provide demonstrations, webinars like today, training, technical support, implementation and customization for structural CAD packages. Software includes Advanced Steel, AutoCAD, Revit, which is what we're looking at today, Navisworks, ReCap and Fusion 360, and also the BIM construction products as well, and the cloud-based products. My contact information is there. It is in the handout. So in the GoToWebinar interface, you will see a little handout. So my information will be in there if you need to reach out for me for whatever reason. If any of you are new to Greatech, a couple of key points about Greatech. We are over 30 years old, headquartered out in France. We are we are quickly becoming one of the largest Autodesk partners worldwide. As well as an Autodesk partner, we do produce our own software. So we have 100 staff out in our research and development center out in Romania, providing our own software such as all the power packs to sit on top of the Autodesk products, and our own software such as Advanced Design. And we are here to work with you guys, our customers. So on technical support, we have a 98% excellent or good feedback, and that's over 50,000 support cases per year. And with our training courses, we do deliver over 3,500 training courses globally every year. So why Greatech? Well, we are one of the only companies that can help you from the start of your project to all the way through to the end of the project. And we've broken that down into what we call our 4 key pillars, which are create, simulate, fabricate, and manage. So create is using the Autodesk products and enhancing them with the Greatech Power Packs. Simulate is then taking that model and making sure that it will actually work in a real world environment. So we have our own structural analysis package called Advanced Design to look after that. Fabricate is then taking those BIM deliverables through to the finished fabricated product, and that's what we're going to be spending quite a lot of today looking at, because Advanced Steel does sit inside the create and fabricate pillars. But we do also have our own tools for workshop management and site delivery, and those are Advanced Workshop and Armor Plus. And then finally, we have manage. So every project that you work on will produce documents, documentation, data. Usually that data needs to be collaborated with an external common data environment. And if you're working on multiple projects, you might have to deal with multiple common data environments. So we have Greatech OpenTree that will look after all of that for you. Now, today is a fairly high-level overview of what we can do with Advanced Steel. I don't have enough time to go into everything. So we have what we call our Greatech content portals, and there is a dedicated Advanced Steel content portal. There's now up to about 60 hours of webinars that you can watch on demand. This session is being recorded and it will get uploaded to that content portal. So I will reference quite a few webinars today. Go and check them out in the content portal. And if you're new to Advanced Steel and you are more AutoCAD or Revit focused, I've just put the Advanced Steel content portals and blogs but there are AutoCAD, Revit blogs, content portals. There's an AEC content portal. So there's lots of resources available from Greytec. So we do have our blogs. So the blogs are 6 years worth of tips and tricks. And then if you are a Greytec customer, if you buy your licenses and your power packs and your technical support from us, you will have access to our Greytec Advantage portal. So this is a dedicated portal just for Greytec customers. So in the past, we've run BIM Up conferences, so our online 3-day conference. We've recently just finished our Advanced Deal user groups. If you miss those events, they are available to watch on demand for Greytec customers via the Advantage page. If you don't have an Advantage login, please speak to us on tech support or speak to your account manager, and we will get the logins activated for you. And obviously, this is probably where you found this event. On our greytec.co.uk events page are all our upcoming events. There are loads of events upcoming for November, and we will shortly be announcing the ones for December, January, and February. Okay, so let's crack on with what we're going to look at today. We're going to look at, like I said, an introduction to Advanced Deal for engineers, or workflows for engineers with the AEC collection. So we'll start by actually putting connections on in Revit, in case you aren't familiar with the connection tools inside of Revit. We'll then look at the Revit to Advanced Deal transfer. We'll then give you an introduction to Advanced Deal, for those of you who aren't familiar with Advanced Deal. Then we'll look at the fabrication output from Advanced Deal. We'll then look finally at the Advanced Deal to Revit synchronization. Now, the one thing I haven't asked, can everyone see my screen and can you hear me okay? No one said anything yet, so I'm assuming that you can, but before we go any further, I better just double check. Thank you, Ilias. That's perfect. Okay. Thanks, Matt. Yeah, okay, perfect. Okay, so connections in Revit. So if you're using Revit and you're modeling structural steelwork, you can actually load connections inside the Revit project. So either in the steel tab or the structure tab, you've got to click the little drop down here, and I'm going to show this in action in a second, but you do need to actually load in the connections that you need. If you've got connection standards, you can transfer them using, or connections can now be transferred using the transfer project standards. If you're completely new to this, to see what a joint will do, just hover over the connection and the flyout will show you the selection order that you need, the profiles that the connection will work on, and then a brief description of what the joint can achieve. So let's actually go and have a look at putting on some connections. Oh, not quite. Okay, sorry, I'm getting ahead of myself. We'll look at actually what we need to do to see them. So you need to be in level of detail fine. If you're in any other one, you won't actually see the individual elements. You'll just see a symbol. And if you're new to steel connections, they do have their own visibility graphics category. So just make sure they're turned on. And then once you've applied a connection, you can just copy or mirror the connections as you would anything else in Revit. For Revit 2020, there is a new command called propagate connection. So you choose the connection and then you choose propagate. And what that will do is it will look for the elements with the same section and section sizes, and then it will apply that connection automatically throughout the model for you. If you don't want something to get a connection, what you do is you just isolate it and then the system won't propagate it for you. Okay, so as I said, we don't have a huge amount of time. We've only got an hour, and I want to show you obviously why Advanced Deal is beneficial to you. So we are going to keep this really basic. I have a real basic steel structure in here. We've got some columns, we've got some structural framing, and obviously I'm starting in Revit. So everything that I've modeled here is Revit structural columns, structural framing. So we did say we would start with connections in Revit. So what we'll do, just going to turn on my mouse highlighter so you guys can see where my mouse is. There we go. Now on the structure tab we do have connections in here, and we do have a steel tab, and we've got connections in here. It's obviously the same in both. Now to load a connection in, what you have to do is click this little arrow here to go to the connection settings. Now I'm using one of my own, I think I'm using one of my own custom templates in here. Just thinking about it at the moment. There we go. Now I have actually loaded these connections into my template file already, so they're available to use. There are different groups of connections, and you can choose which ones you want to load in, or which ones you don't want to load in. Now what I'll do is I'll start by selecting a column. We'll go to the structure and we will add a connection. Now that will start with a generic connection, but what I can do is I will just choose a base plate connection in here. Now you do have to be patient with these. What it will do is it will model, don't need to worry about the warning messages, it will model, and it is, the column has changed to cyan. So if you see that, that's the system thinking about and actually applying the connections in here. So what you'll get then is the system then puts on the plate, the welds and the anchors automatically. And what we would do is we would click the edit type button, popped up on my other screen, and the type at the moment is base plate. Now what we want to do here is we want to duplicate that, and obviously someone is going to be actually designing this connection. So I'm going to call this BP1. And then once I've duplicated the type and I have my own custom type, I can click the modify parameters, and that will open up a dialog box for me. And then I can actually go through and I can make changes to how this plate is created. So I can set the thickness to 20 mil. Now maybe we need to allow for a pack and grout value under here. So under column shortening, I can say shorten the column based on a value. And if we've got a 20 millimeter base plate and we want 25 millimeters, say, for pack and grout, I would shorten the base plate by 45 millimeters. So that's going to shorten my base plate. Now within these joints, we can set everything that we want to do with this base plate, the anchors and the well. So the way these connections are put on inside Revit is slightly different to the way that you guys as Revit users maybe are used to things happening, because you would go in and modify the family, for example, whereas in here we're actually applying a connection separately. Now this technology in here and the steel tab in Revit, it is new technology for you as Revit users, but that technology has actually come from Advanced Steel, so that's why it does work slightly differently to the way everything else works inside Revit. So what we can do in here, I can go to base plate dimensions, and you can see with all of these joints, what they will have is they will have a picture in here, and it will say we've got some dimensions with some labels on. Those relate to everything that we can see happening in here. So all projections are equal, so that's giving me a 250 mil projection in all directions. That's giving me a 500 by 500 overall base plate. We can then go and change the corners if we need to. I will change the anchors, we'll make them 400 long anchors. And what we'll do, we'll say that we want 3 anchors at 200 mil centers. In fact, we'll change it the other way. So we want 3 anchors in that direction at 200 millimeter centers that way. Then the welds. Now, previously you might not have been doing the fabrication details. Obviously, that's what we're looking at in today's webinar. If we want an 8mm fillet weld, for example, all round, we need to put that kind of information into the joint itself, and then we can, when we run the drawings from Advanced Steel a little bit later, that information will come through. So just remember there that I've put an 8mm fillet weld on. Then we've got stiffeners and holes, stiffeners and plates, sorry. You can add in shear anchors, you can add in extra stiffeners, web stiffeners, flange stiffeners, outside stiffeners if we need to. You'll see that most of the options in this dialogue in here are grayed out. So if they're grayed out, it's just a case of enabling things and ticking things if we actually want them on. The same for holes. Do we want galvanizing holes? If we're going down to fabrication level of detailing, then we need to put that information into our modeling environment. So we're creating models with a higher level of information. So there's my type BP1 created. Now what that's going to do, that's going to update itself. And there we have that model, that base plate on the columns. Now, if I go to my ground floor plan, we'll save the project. Now, the one thing that we can't actually see in here at the moment is that connection. All we can see is this green circle, which tells me there is a connection on in there. That's because I'm in level of detail course, medium. If you want to see the connections, you need to be in level of detail fine. Now, if you are in level of detail fine and you still can't see things, there are some new visibility graphics categories for structural connections. So you can see in here we've got the structural connections. You obviously also need to make sure that those are ticked and enabled. So there's my base plate. I can select it and I can copy it, and I could say, right, we'll copy it from there to there, and then I could just keep copying it around. But on a bigger project we wouldn't want to do that. What we can do with these steel connections is if I select the connection and I right click, we have this option in here, propagate connection. Now what propagate connection will do is if I click propagate connection, you'll get this message, and this is actually quite important. When we're applying these steel connections or items from the steel tab, there are certain things within Revit that you might be used to using that won't work anymore. So cut with voids, reference by planes, your start, end, join cutbacks, they then become ignored. And unfortunately at the moment we can't put these steel elements inside groups or assembly. So once we apply a connection, certain things that you could do inside Revit are no longer available. Now what's happening here? The system looks for structural columns with that exact section size, and it puts these connections on for me. And you can see, if I look at the properties, these are all base plate ones. Now if we had columns that were a different size, just to show you, I'll just undo that for a second. If I change the section size of this, and I won't change it massively, I'll just change it to the next 254 available in the system. If I now go and right click and choose propagate connection, the system won't put that connection on in that location because the section size is different. So the propagate connection is excellent, excellent at allowing you to place the same connection on structural columns or structural framings with the same section sizes. So we'll just change that back, and then we'll just propagate that again. Now it won't do it automatically, but if I select that and I choose propagate connection, it knows that all these other ones have a base plate on them, but it knew this one didn't. So that is the system putting that kind of information on. The next one I'll put on, just to show you, because we're going to do some of this in Advanced Steel as well. The next thing that we're going to put on, we'll put on a little fin plate connection in here. Now, if we've got two beams as an input, you choose your main beam first, and then we choose the secondary beam. And then in the structure or the steel tab, I would say I want to place a connection. And then we can look for the connections that will work between those. So I'll put a shear plate connection on, or what in the UK we would call a fin plate connection. Now that will use, again, the default settings in there. So we'll do the same again. We'll edit the type. We'll duplicate it, and we'll call it fin plate 1. We'll just keep the naming quite straightforward in here today. And then we can edit the parameters, and then we'll spin this little dialog box is interactive, so we can spin it around so we can actually see what we're doing in here. Now what we can do in here, the plate layout horizontally, I can say I want 50mm centers, one number of bolts, and I want my end distance to be 50 as well. Vertically, what I can do is I can say, right, from the top of the beam, I want the plate to start 20mm down. We want 25mm edge distances, and I want those bolts at 70 centers. So maybe what we'll do, we'll start at 30. We might get away with 30 and 30. And then the plate shape, we will change that to default, which will just remove those chamfers for me. So again, I can click OK once I've modified the parameters. Then both beams will turn cyan. This is the system updating that connection. Now that connection is between the primary beam is a 254.146.43, and the secondary beam is a 178.102.19. If I propagate that connection, it has to, the system will only apply it to areas where those conditions are met, those sections are met in here. So you can see we've got a fin plate. Let me spin myself around, apologies. We've got a fin plate there, we've got a fin plate there, and we've got a fin plate in there. Now I could keep going through the model. I'm going to show you that we can apply these connections in Advanced Steel. So we're going to just save our file there, and that's all we're going to look at for the connections in Revit. I have done a full hour webinar just on connections in Revit. That is available in our content portal, which you have the link for in the handout. So there's a real brief introduction to the connections and what we can do inside of Revit. Now what we're going to look at is how we can transfer our model from Revit to Advanced Steel. So in Advanced Steel, all the import, export, synchronize options, they are already installed. So if you're an Advanced Steel user or you work with an Advanced Steel user, you don't actually need to change anything. For Revit, we need to install and add into Revit. So if you're using Revit pre-2019, you would download the extension from your App Store. Just search for Steel and then choose the correct version. Now, when you're installing any software, it's just best practice to close the actual software before you try and install any add-ins. If it's post 2019, that's not showing on this slide deck. If it's post 2019, go to your Autodesk account or your desktop app and search for Advanced Steel Extension, and that's where you'll find it post 2019. Once it's installed, you'll find it under the Add-ins tab and then Advanced Steel Extension. So I'm just going to go and transfer that model from one to another. Now that we have our I haven't finished everything, like I said, we're going to do a little bit of this in Advanced Steel, but we have the basics of what we want done in Revit. We then might want to pass it into Advanced Steel to actually do the next level of detailing and run the fabrication output, and that's obviously what we're here to look at today. So, as I said, we use the Advanced Steel extension for Revit. So it needs, once it is installed, you'll find it under add-ins and you've got Advanced Steel Extension. I will just double check my settings, so that is all fine. It's popped up on my other screen so you guys can't see that, but there's a couple of settings. Now myself and my colleague John Bennett have done loads. We've done about 10 webinars on this transfer mechanism. So all I'm going to do today is I'm going to click the export button, click OK. That's going to create an SMLX file, which is the transfer mechanism between Revit and Advanced Steel. And there's my file exported. And then what I'm going to do, I'm going to move into my Advanced Steel. So just going to start a new Advanced Steel template file. Now, if you guys are completely new to Advanced Steel, Advanced Steel is built on top of AutoCAD. It's Autodesk, I think we talked about this previously, it is Autodesk's steel detailing package. What I'll do, we'll just go to a southwest view and a realistic view in here. Now what we can do in Advanced Steel, we have an export and import tab, and over here on the left hand side we have a Revit panel. So I'm just going to choose import from Revit, and then we need to go and find the folder. So that's going to be in here, Advanced Steel for Engineers. There's my SMLX file. Now it's wanting to map some materials because they are different packages and they do have different materials in both of them. But that will have then recreated everything that I created in my Revit model in the, and it will have brought everything through, including the connections. Now I can select something in here, right click and go Advanced Joint Properties. That joint dialog that we looked at very briefly in the Revit side of things, you can see in here this is standard Advanced Steel technology. So when we saw it inside of Revit, it's actually the Advanced Steel technology put inside Revit. You can see in there, there's the 8mm fillet weld all round. There's my fin plate connection. Our grids have come through. We do have grids in Advanced Steel, obviously. And the other thing that will have imported in Revit, I had levels. and these are my levels that have come through from Revit into Advanced Steel. So I'm just going to save that. So that we don't lose anything that we're doing. And we'll just call this for today Steel Import. So that's how we can transfer from Revit to Advanced Steel. That. And everything will come through. Now I did just mention that a second ago in that example. So if you're new to Advanced Steel is built on top of AutoCAD. If you are modeling things, users do just model the beams and columns as you would do in Revit. Then we can look to apply the connections from a vault of 200 plus connections. And then we've got automatic macros to place stairs, railings, ladders, purlings, anything that is a structural steel element or an architectural metalwork element, sorry. We can place those automatically in Advanced Steel. So we're going to actually have a look at that, and we're going to look at what we can do with some things in Advanced Steel. Now that we have got our model into Advanced Steel, I just want to show you guys that we can put connections on as we did in Revit. So it is up to you guys where you want to put these connections on. But in here, for example, I've got an eaves haunch to a flange connection. Choose my column, choose my rafter. The system will then put the connection on, and what we can do, doesn't matter which package you use, whether it's Revit or Advanced Steel. In here we can apply the connections, and as we did before, I can select that, right click and choose propagate. And that will do a similar thing. It's looking for those sections as an input. The other thing that we can do in Advanced Steel, which is beneficial when we're getting down to this level of information or this level of detail, is I can select these items, and within Advanced Steel I can run a clash check. So on the fin plate that we created, the system found no errors. I can put a little window around these items. Now I haven't put a connection on for this beam in here, so I'm going to deselect it, and I can run a clash check, and again the system found no errors. If we look in here and I run a clash check, I've got errors because there are clashes between all of the items because we haven't actually put any connections on yet. So that's the system will in Advanced Steel show you the clashes, and if I go to a 2D wireframe, it will actually also mark in red as sort of a temporary marking. It will mark where the clash is as well. So we can do that inside the Advanced Steel environment. The one thing that we're going to put in for today, we're going to put in a little staircase just to show you what other elements we can model in Advanced Steel. So I'm just going to, just because we're pressed for time, we want to show you the NC and the drawing output in here. We're just going to move this staircase over. Let's move it over 2 meters. We have our what we would call our sort of nosing line. Now we might want to switch back type stair. I just don't have enough time to go into that today, so I'm just going to draw it as one long stair, and then So what we have for our Advanced Steel macros, things like staircases, purlins, railings, ladders, access ladders, we have macros in Advanced Steel where you choose your input points and the system will then create things like the staircase based on those input points. Yeah, that's the maximum number of steps we can have without needing a landing. So we'll leave that as it is. And what we'll do, I'm just going to make my landing a little bit longer in there. Just so it actually extends. But what we can do in these stair macros, for example, we've got all these different tread types in here. So 1, 2, and 3 are for grating type treads. Number 4 is a timber tread, and then 5 all the way through to 21. These are what we call our folded plate type treads. We can change the section size, the stringers. There's all sorts that we can change in here, and then we can add macros to these items if we want. What I'll do for you guys, we'll put a little bit of railing in the back here. I'll just show you some of these macros that we can put on, but then we'll spend the last sort of half hour of our session looking at the drawing outputs and what we can do with that. So there's some handrail, we can put some connections on them. Just sort of showing you some of these, and then what I'm going to do is I'm going to go and finish it because it will take me a little bit longer than the time we have left to do this properly. But these in Advanced Steel are joints. Now we can joint copy these items, so I can take that information and I can say, well, apply it to this beam, and this beam. Start the handrailing here, finish it over there, and the system will copy that information around for me. And there is my railing in there. If we want to model different beam sections, we do also have in here welded beams. So if you're getting into the bigger sort of fabricated stuff, we can do that in Advanced Steel. We have lots of plate work that we can do in Advanced Steel, so I'll just very, very quickly, just as an example, we'll just put in a little plate in here, and then I'm going to put in another plate at that point in there. And then if I want to fold them together, I can, so these are just 2 loose plates, I can select both plates and then the system will actually put in a fold for me. So Advanced Steel now sees that as one object. There's lots we can do with plate work, with beam work. I just obviously don't have enough time to give you guys a full demonstration of Advanced Steel. We're looking at it more from the structural side today. So what I'm going to do, I'm going to just finish up my model and actually put these connections on, make sure everything has a connection, do all the clash checks. I'll finish that off in the background, and then we're going to look at all the drawing output that we can do within Advanced Steel. So, like I said, we'll move on to the fabrication output next. So once we have done the modelling, Advanced Steel can then break that model down into the single parts and the assemblies. The part and assembly drawings will run automatically, and it takes, on an average machine, 2 to 3 seconds per drawing. That's all of views, all the dimensions, and I'm going to show all of that in a second. I will explain it, but Advanced Steel does do it differently. Things aren't stored in the project like they are in Revit, or even if you're using 2D AutoCAD, where you've got model and paper space. All the output from Advanced Steel is created separately as separate DWG files. We then have lists or schedules in Revit terminology, which we then create automatically. And then we look at the CNC data for automatic fabrication. That's then created in seconds from Advanced Steel because it's just data written to a particular file. So what I've done here, I've just tidied up the model. I've actually put the stairs on, the railings on properly with the connections. That's all done within the macros. I've run my clash checks. I do have two tiny clashes in the whole model, but for today's example, I'm not too worried about those. The other thing that we can do with Advanced Steel, if we're going down to fabrication level of detailing, we want to check what's attached in the workshop, for example. We've got these commands on our tool palette here, but I can say, show me what's attached in the workshop. And the system will mark in red everything that's attached in the workshop. So I can do the same for the railings. The railings are all at the moment one piece. I can do the same on our columns. So when we're going down to this level of detail, or this level of information, the system's going, Advanced Steel is going to give us that information. The only thing I have forgot to put in is the project information. For the project, we will just call it Advanced Steel. Make up a project number. The client will put engineers. I'll put my colleague Alec as the person checking the drawings, and I'll be the one who's detailing them. Now, before we can run our drawings and things like that, what we need to do, we need to number the model. So the system is going to decide what's the same and what's different. So if I click the numbering dialog, just going to set my rules up in here, and then I'll click the OK button. And then what Advanced Steel is going to do is going to check to see what items are identical. So those three columns in the back there, they're identical. The three columns at the front are identical. My rafters, the three rafters are identical. Then we're down into the sort of trimmer beams and different bits and pieces in there. And then onto the railings and the gratings and the stairs. So anything that is the same will be given the same item number. Anything that is different will be given a different number. These unique numbers then allow us as Advanced Steel users to run the drawings as we want to run them. So I'm just going to save that. And I'm just going to just set up a couple of little things. I don't really have a huge amount of time today, so I'm just presetting a couple of things in here. That should be fine. Now we actually want to run our fabrication drawings, and this is where you'll see the big difference between using Revit for steelwork or doing it in 2D AutoCAD. I know I've mentioned Revit a lot today, but we could still, it could still be a benefit to engineers who are doing their work in AutoCAD. Is the huge difference you'll see is the fabrication output. So once I've done my checking and my numbering and everything like that, what we want to do then, we want to run our drawings. So I'm going to click this button here, all parts A4 to A1 single BOM. We'll get this little dialog pop up here. I'm just going to click OK. Then what we have to do is we just have to wait for the system to do what it needs to do and run through the process. So the button I clicked there said all parts A4 to A1 single BOM. So all parts is every part in the model that has a number. A4 to A1 is these sheet sizes. So how Advanced Steel works is it says, can I fit the plate onto a fab drawing? And can I fit it on at 1:1 scale, yes or no? If it can't, it'll then go to 1:2 scale, then 1:5, then 1:7.5, 1:10, 1:15. When it gets to 1:15, it says, okay, well, I can't fit it on an A4 sheet. So then it'll try an A3 sheet, go through the scales, then an A2 sheet, then an A1 sheet. If it gets to 1:1, at scale 1:15 or 1:20, it's obviously an enormous part, but then it's run out of rules, and it will just put the item on the sheet anyway, and we'd have to go and manually change that. Now, how the system is working in here. Advanced Steel does work differently to Revit. So in Revit, everything's created inside the project. When we're running these, what we call processes, Advanced Steel creates these items as separate files. So if I go to where everything I've been saving today is saved, my Advanced Steel model is called Steel Import. As soon as I push that button to create the drawings, Advanced Steel creates a subfolder with exactly the same name, and then in there's a folder called Details, and this is Advanced Steel creating all of those piece part drawings. So each item gets its own drawing because the button I clicked is single BOM, and BOM is bill of materials. So we'll just wait for this to finish running. So the system is running each drawing, and it's taking 1 to 2 seconds per drawing. Now that has run all of those part drawings. So what I'll do the same for the assembly drawing. So the way Advanced Steel works is each individual item will get a part drawing, and then those parts are welded together to form an assembly. So Advanced Steel will give you an assembly drawing as well. So the process is exactly the same. I've clicked the button, all assemblies, A3 to A1 single BOM. So it'll start with A3, run through the scales that have been set up. It will then do one assembly per sheet, and it will put a bill of materials on that sheet as well. So you can see if I go to the folder structure in here, we can see the system creating these drawings, and again we just got to wait for it to finish creating those drawings. Now once our drawings have been created, we want to go and view these drawings and have a look at what the system has done. So we have what we call in Advanced Steel our document manager. So put it up on the other screen. And these are all the documents that the system has created. So 4 to 5 minutes for all of those drawings. And what the system does, if we do a preview on one of the fittings, we'll just sort of run you through some of the fittings that we have in here. Excuse me, that's one of our tubes. We've got a lot of tubes in here, so let's look at some plates, see if we can find some plates. Loads of tubes. Okay, there's one of our flat bars. So what the system will do, the system will give the overall length. Any angles, it will put an actual angle dimension on there. It will give the cut sizes. The title block gets filled in automatically. And at the top here, the bill of materials is, again, that's our BOM, that's our bill of materials, that gets filled in automatically. Now I'm running a completely out of the box Advanced Steel. When we print these to PDF, they will print in black and white. There's a plate, so that would be more sort of steelworkers we would, structural steelworkers we would recognize it. So again, overall in the X, hole positions in the X, overall in the Y, hole positions, and then what hole site quantities we have in there. for our, what we call in Advanced Steel, our main parts, these are the beam elements. Again, we get that kind of information: overall length, notch information, what the quantity is, and that gets obviously filled out automatically. There's some more tubes. There's lots of tubes in there because we've got quite a lot of handrail. Then we can look at the assembly drawing. So A for assembly drawings. The system will then say, right, the assembly is called B1. It will use those fittings and main part numbers to locate the items. It will give us our overall fabricated length. It will then give us our end plate lengths, and then the location of the end plate relative to the top of the beam, so the people who are fabricating it know what information they require. We'll see if we can show a couple of drawings if they've got a bit more information in there. There's quite a good one. There's one with holes in and some little fin plates as well. So you'll get a front view, again with the overall information. Then the system will start to locate these welded pieces that we have on there. Any holes that we have on there, the system will give the dimension between the holes, but it will also give an overall running dimension. We have holes in the top flange of the beam, so the system is giving you the dimension between the holes and the running dimension. It's also then locating these attached plates on the top here, and that's putting it in as a separate chain. And then in the bill of materials that we can see here, it says to make 1B3 you need all of these pieces. So the system is giving all of that information automatically. We can also run lists, as I would refer to them in Advanced Steel. I suppose you guys would refer to them as schedules in Revit. So we'll start, I'll just run a couple of examples of what we can do in here. So we can run a material list. Now, in Advanced Steel, it's looking at the whole model. So it's not looking at a schedule for just structural framing or structural columns or plates. We can list everything that we need in here. So it will give you the total length required of tube or flat bar or PFC, and then the system will break it down into the actual individual lengths for you, and it will list the plates in there as well. So that's a material list. For today, I'm not going to save any of these. We can run what the system calls an assembly list. Again, so for the workshop manager, this will help the workshop manager to actually figure out what parts are needed where. So for RL1, when they're making railing 1, those are all the pieces that they need to make railing 1. So again, that's quite a useful list for the workshop. Then we'll look at what we call the loading list or the delivery list. So what items are being delivered to site. And that will just give the finished assembly, the quantity, and the main part section size. And then the workshop can tick that they've loaded it, and site can tick that they've received it. So it's useful for deliveries. And then the last one I'll run today is a bolt and anchor list. So this will run. And all this is doing, same as Revit does, it's just extracting the data or the information from the model and applying it to a set of rules or a template file. All those lists can be exported to Word, PDF, Excel format, Notepad format. We can run GA drawings. I'm just really struggling for time today. GA drawings. We just put a camera in the model. I'll just do one as a 3D view just so you guys, just so I can show you how it works. So what we do is we put what we call a camera in here. We choose a set of rules to apply to that camera, a bit like a view template, and I'll call this an overall 3D. And then what I can do is, it's the same palette that I used to run the drawings, drawing processes. This time I could just say camera selected, click OK on there. That will then extract that information and it will run me a 3D view of the whole model. And if I open that, that will take me into my drawing, and then there's my 3D view. I can then, if I want to, I can then start to add my own labels to it if I want. And when I'm labeling, I can label any object. I don't have to load in extra tags for different bits and pieces. I can label whatever I want in that environment. The final thing I'm going to show you for output in Advanced Deal is the automatic CNC output, or the NC output as we would call it. So NC files is numerical control. So I'll run NC files. So this is for our beams to be put through a drill and saw line, and for our plates to be cut on a plasma cutter, a laser cutter, water jet machine, whatever your fabricator uses. Now for the NC files, I literally just click the NC button. The system will create the NC files based on an international standard, and that the system has actually finished the NC files. And for the plates, what I need to do, I need to use a filter in here to select the plates. Click the DXF button because we might want DXF files for plates. And again, if I hit save, we'll go back to our document manager to look at that information. And what I will then do, I will minimize details. And we now have DXF for all objects. So these are my plate elements. So that's my one-to-one cutting profile to load into the plate machine. And then for NC files, this is just my data from the model that says you need to get a 355JR I-beam that's 254 by 146 by 43. You need to cut it to this length, and then you need to put notches in and put some holes in as described in the code. So that's how we can do our automatic output from the model. So that is a real quick introduction to Advanced Deal. The last thing we will look at, so only a few minutes, so we're nearly back on schedule, is actually syncing these changes now back with Revit. So if we obviously started in Revit, we've brought everything to Advanced Deal, we've added lots of extra items. We don't want we want to update that Revit model to reflect all the changes that we've made in Advanced Deal. So with the Advanced Deal extension, you do have a synchronize option. So what we need to do is we'll load the SMLX file, select and tick the changes that we want to apply, and then click apply all actions. Now the system will compare what's in the Revit model to what's in the SMLX file, and will advise whether things have been added, modified, or deleted, and then we can choose which actions we want to apply. Last little point there, if your materials match, the synchronization works a lot better than if you just had your Revit materials and Advanced Deal materials as separate entities. Okay, the final thing that we'll finish with today is we want to synchronize our Revit model with the things that we've added in Advanced Deal. So what we will do, we will export from Advanced Deal, and we will call this Advanced Deal export. That will create an SMLX file. That's finished the SMLX file. And then we'll go back to our original Revit model. Don't need that beam. That was me just testing something. So this is the Revit model with no staircase, all the connections aren't finished. What we can then do, we can go to the Add-ins tab, the Advanced Steel extension, and we can then choose the synchronization option. Now that's going to open up a new tab, and then I can then go and choose to load an SMLX file. So if we choose that Advanced Steel export option, the system will then compare what's already in our model to the items in the SMLX file. So you can see that we have modified some beams, we have appended or added some beams, we've added some plates, and we've obviously added a lot of connections. So I will select everything in here, and I will tick the box and I will say apply all actions. That will then go to, well, the system will look to update my original model, and it will apply all of these changes. Now this is okay, so it's looking for one beam, it's looking for 100 by 10 flat bar. So I need to go and load in that flat bar, so we need to go and look in Revit 2022. And we need to go structural, what are we looking for? Structural beams, so structural framing, steel, and there should be, is Europe specific, we're looking for a flat bar. And then in here I can filter, it's right there, 100 by 10. So if we can't find it in Revit, we will need to load it in. And then I can click OK. Now this might take 5 to 10 minutes, so what I'll do, I will just pause the video that I'm doing here, and then I will come back when it has finished doing what it needs to do. We'll actually give it a second. These are my curved loops on the end of my handrail, but it is actually attempting it. So you can just see in the background there the staircase being built. I can't move this dialog box out the way, I'm afraid. So all these little warning messages I'm getting is the loops in the end of the handrail that I have. You can see in the background there the staircase being built, the connections being built, and everything being updated. Okay, so did take an extra 5 minutes or so, but if I close this reporting dialog down now, we can see we have our staircase, we have our connections that were missing earlier on, we have the extra bits and pieces, did actually miss a connection in there earlier on, but like I said, we only have an hour. There's an awful lot in our content portal that shows a lot more of these workflows in greater depth. And that takes us to the end of our hour session. Thank you all for attending. Hopefully you found that useful. If anyone does have any questions, please type them in the GoTo webinar dialogue now, and then I will, if I can answer them live, I will answer them live. If not, I will answer them offline. Like I said, today has been quite a high level overview. We have 10 plus webinars on the Advanced Steel to Revit workflow in our content portal. We've got 50 plus webinars on just general Advanced Steel things in our content portal. So definitely go and check out the content portal. You'll be able to find the link in the PDF handout again in the GoToWebinar interface. And I can't see any questions coming through at the moment. So if there aren't any questions, we will end our session here. So once again, thanks for watching, thanks for attending. The session has been recorded, so it will be uploaded to our content portal, and it will be uploaded within a couple of weeks. So check the content portal in a couple of weeks, and then you can watch a recording on demand. Once again, thanks a lot for attending. We are running tomorrow. My colleague Alec is running between 4 and 5 p.m. An introduction to Advanced Steel, looking at material handling. So chutes and hoppers, and working with the sort of manufacturing environment. And then Friday 2 till 3 p.m. I am running a webinar on an introduction to working with timber in Advanced Steel, because we can model timber elements. So if you haven't already signed up for those, go to our greytech.co.uk events page and sign up for those. And we'll hopefully see you tomorrow and Friday.